Hey everyone, here is the second part of the implicit differentiation video. In this video, my main goal is to show you 3 examples just so you get the hang of the whole process, and then there'll be a couple you tries at the end for you to do, which we'll go over in class when I see you again. One thing I want to point out about implicit diff before we start all these is that what we're really doing is the chain rule. So I just want to point that out here. I can make that, now we did this in the first video, but I'm going to rewrite it and make it look a little bit more like layers. And when you hear layers, you should think chain rule. So we have an inner and an outer. And when we do the chain rule, you do the derivative of the outer without touching the inner. And then you multiply by the derivative of the inner. And the derivative of y is dy dx. And this is the derivative of y with respect to x. Now, whenever I do this, our first example, our goal, remember, is always to find dy dx. So we're going to do the derivative of each side with respect to x. So we'll be taking d dx of each side. And remember, d dx is the command that's telling you to do the derivative with respect to x. So this step here is not needed. I'm just emphasizing that what we're doing is the derivative with respect to x of both sides. I haven't actually done a derivative yet here. I'm just emphasizing the variable we're thinking of. So my first step would be to do the derivative of each term with respect to x. So derivative of 2x is 2. Plus, and check this out here, I have x cubed times y. So you should immediately be thinking product rule. So I'm going to do x cubed times derivative of y, which is dy dx, plus derivative of the second, 3x squared y. The derivative of a constant is 0. Again, because I want to get dy dx alone, I need to be moving the other terms to the other side. So the term x cubed dy dx is going to stay right where it is. I'm going to move 3x squared y over, and I'm moving 2 over. Last thing I can do is divide by x cubed. So my final solution, the derivative of y with respect to x, is negative 3x squared y minus 2 over x cubed. This here is a Desmos graph of my original equation, and you might be thinking, well, this is a function, so why did I even do implicit differentiation? If passes the vertical line test. There is a vertical asymptote, but it definitely passes a vertical line test. Anytime you graph a function that looks implicit and it passes the vertical line test, it's because you could have solved for y from the beginning. So I could have done x cubed y equals 5 minus 2x. Oops. So minus 2x, so I could have moved 2x over. Then I could have divided by x cubed on each side. And I could have just gotten y equals 5 minus 2x over x cubed. So anytime that you could have done this, and I could have just done a normal derivative with the quotient rule. Let's compare that with this example here, where I could not just solve for y. It's not easy to get y alone, and whenever you graph it on Desmos, it's definitely failing the vertical line test. This is an ellipse, which I believe you saw in geometry. Again, this is the command saying, hey, do the derivative with respect to x. And here we're going to go one step further and actually find an equation of a tangent line. So we haven't done that yet with these videos. And we want the tangent line at x equals negative 1, which is right here. So you might be thinking, uh-oh, there are 2 choices here. There's this y value and there's this y value. And I'm going to show you what's going to happen here. So let's start by just doing our derivative. So x squared becomes 2x minus. Now, this is important here. I'm subtracting xy. So when I do the derivative, I need to put it in parentheses so I can distribute the negative after. So I'm going to do first times derivative of second. Basically, anytime there's a y, you put dy dx. Plus first, derivative first, second. Okay, so that's done. Then I'm going to add derivative of y squared, which is 2y times dy dx, implicit diff. Derivative of a constant, 0. So let's distribute the negative. So I'm now getting this. Whoa. Again, our goal is to get dy dx. So the thing is, I have more than one dy dx here. And using our algebra skills, what we're going to do is keep these terms right where they are and get rid of the terms that we don't want. So I'm going to now have negative x dy dx plus, don't forget that negative in front of the x. So now I'm going to subtract 2x and add y. Okay, so those are canceled. If I have dy dx written twice and I wanted to solve for dy dx, that means I need dy dx written once. The only way to do that is to factor out dy dx because both terms share it. That leaves negative x here and plus 2y here. And then to get dy dx alone, let's just divide by what we don't want. Negative x, minus 2y. So negative x minus 2y. That cancels, so here's my final derivative. Dy dx, negative 2x plus y, negative x minus 2y. Just noticed I forgot to make that minus a plus here. So just fix those three little negatives and make them plus. Okay, so we have our derivative, and we actually want a tangent line. So remember, to write the equation of a tangent line, we always need a point and we need a slope. So to get dy dx, I'm going to need to plug in an x and a y. And the thing is, I only have an x. But we know that if we have an x and we want a y, we can just plug back into our original function and we will get a y value out. So let's take our original, which is x squared minus xy plus y squared equals 7, and let's plug in negative 1. What I did here is I plugged in negative 1 and I did my basic manipulation. I have a quadratic in terms of y, and to solve quadratics we need to factor. So I'm going to have plus 3 and minus 2. So my two y's that I could get are negative 3 and positive 2. And that makes sense because if I look up here, we already saw that at negative 1, I have an ordered pair negative 1, negative 3, and negative 1, 2. So there are two possibilities for a tangent line. I'm just going to go ahead and tell you that I want to do the one at negative 1, 2. They'll always tell you. It's not like you have to know which one to pick. You will be told which one to choose. So let's do the negative 1, 2 one. Proper notation here, dy dx, xy equals negative 1, 2. I'm going to plug the ordered pair into the derivative. Notice I just plugged right in and I got 4/5 for my slope. So let's plug into our point slope form to get the equation of a tangent line. You plug in your ordered pair, y minus y1 equals m x minus x1. There you go. So that is how you can get the equation of an implicit function. Let's do another one here. This time for the example, we're already given the ordered pair we want to use. We have the x and the y. So that's going to save us a step at the end. Let's do the derivative of each side with respect to x. So I'm going to put dy dx after because it was y in terms of x. I'm going to do product rule right here. That would be x and then dy dx plus 1 times y. Derivative of the other side, those are all x terms, so I can just do the derivatives of them without having to worry about dy dx. Derivative of a constant 0. I have two dy dx terms again, so I need to get this term and this term together on one side. I'm going to move everything else to the other side. So these can stay. I'm going to move the y to the other side. So I'm going to subtract this y. It has to go. Then I'm going to factor out, and then I'm going to divide. What I did first is I got, like I said, dy dx terms together. Then I factored out dy dx, then I divided by this whole thing on each side to get dy dx alone. Now we're going to need the derivative at 1, 1. This is the equation that I showed you at the very beginning of the video right here. So we're finally actually doing this one. Now, what I want you to do in your notes is make sure you have all these steps and make sure you're understanding as you're writing down what's going on. And I want you to write down the following steps here with the arrow pointed where the step occurs. So first you use the chain rule to get the derivative of the entire equation, and you include dy dx when doing the derivative of y with respect to x. Then you get all the dy dx terms together on one side. Everything else goes on the other side. Then you factor dy dx out. Then you divide to get dy dx alone. Make sure you write that down because in a few months, whenever you look back on this, you're going to want the steps to guide you through the process. To get an actual derivative at 1, 1, I'm going to take what I had for dy dx. Notice your calculus notation here, Leibniz notation, and I just plugged 1, 1 in for every x and every y. So here's my slope, 1/5. I already have the point, I have a slope, so I can really quickly just plug in to get the equation of the tangent line. It's one more easy step. So y minus y1 equals m x minus x1, and there you go. Now, in order to test this, if it's actually the right equation, what we can do is we can go to Desmos and plug it in and see if we actually get the same thing. the implicit graph on Desmos. I'm going to type in exactly what I got. So y minus 1 equals 1/5 x minus 1. And there we go. There's our tangent line at 1. Notice it grazes the curve at one point at 1. And I know that the tangent line's touching for a second time here, but we're only concerned in the general area, is it touching the curve at 1 point? So that's how you can check if your tangent line is correct. So I have 3 U-tries for you to do. Now make sure you sketch the visuals for each just so you can see the non-functions whenever we look back on your equations. So here are the 3 U-tries. One of them is a multiple choice problem from 2008. And so they love implicit diff for multiple choice problems. There's always going to be a couple of them on the exam. And for this one here, I'm just going to tell you what you should get so you can get some feedback right away if you're doing the right thing. You should get choice D. If you didn't get choice D, check to make sure you actually did implicit differentiation. Now notice your chain rule here. You have an outer and you have an inner. And when you do the derivative of the inner, you're going to need to use product rule. And when you're doing product rule, you're going to have to do implicit differentiation. So just be really careful with your steps. Don't rush through it. You have your second example, find dy dx. So you're going to go through these steps that you wrote down right here, highlighted in yellow. And then for the last one, I gave you an implicit function, or an implicit equation, I should say. And then I'm going to give you an x value, and I want you to find the derivative with respect to y. So you're just getting the slope. You're not doing the equation. And notice you only have an x, so you're going to have to plug back in to get a y like we did, where was it? Like we did right here. You have to plug your x back in the original to get your y. So I'm going to leave this screen up here. So pause the video and do these 3, and we'll check them in class. All right, have a great rest of your weekend. Bye.